Good afternoon. Welcome to NASA's Kennedy Space Center. I'm Stephanie Shearholtz from the Office of Communications. We are here preparing for a launch Sunday morning at 10:21 a.m. Eastern Time of SpaceX's 7th commercial resupply mission to the International Space Station. It will carry more than 4,000 pounds of supplies and cargo for science investigations and reconfiguring the space station for a new era of U.S. commercial crew spacecraft. Earlier today, we heard about some of those science investigations, and tonight we'll hear about preparations for the mission itself. So joining me today are Michael Tafferdini, the International Space Station Program Manager, Hans Königsmann, Vice President of Mission Assurance for SpaceX, and Kathy Winters, our Launch Weather Officer for the 45th Weather Squadron. So Mike, I'll pass it over to you. Talk about NASA's preparations for the launch.
Thank you, Stephanie. So good afternoon, everyone. On board today, we've given the crew the go.
Mike.
Oh, I'm sorry. Sorry about that. You guys also want to hear, huh? All right. Well, good afternoon, everyone. The crew has been given a go by the ground team for the arrival of the Dragon spacecraft, and so they're ready to go. This is a little bit unique in that typically we have two U.S. OS crew members do the capture and the berthing activities along with the ground team. This time around, because we're down to 3 crew, we'll let Scott do it with Gennady, and Gennady will be supporting him for both the capture activities and the berthing. And so it's again truly an integrated crew doing all the tasks that need to happen on board. We have talked to you earlier today about the science that's going to take place. I'll tell you a little bit about the reconfiguration. Over this last couple of months, we have done the first steps in the configuring of the International Space Station to have commercial docking capability or autonomous docking capability if necessary. And so with that, we moved the what we call the PMM. It's basically our storage closet that was on Node 1 Nadir, and we attached it to Node 3 forward. And with that, we cleared out the port necessary to allow berthing to occur on Node 1 Nadir. This is really the first step in the process. The next step is to add this docking adapter, the first docking adapter, which is on SpaceX 7. So it'll bring up the docking adapter because we're at 3 crew during this period, which wasn't the original plan. We'll store the docking adapter on board ISS, and then when we get back up to 6 crew, we'll move the docking adapter onto Node 2 forward, which is where the shuttle traditionally docked to space station. So it'll be on the forward port in the velocity vector. And then after that, we have a couple of EVAs planned. One will be to do the attachments for the docking adapter, which is a manual task. The robotic arm helps us get it there, but then the crew installs it manually and connects the wires. In addition to that, we will disconnect node PMA3, which is on Node 3 port right now. And that'll put us in a process, allow us to, at that point, move whenever we're ready to move the PMA3 to Node 2 Zenith, which today is our backup berthing port. And once that's done, SpaceX 9 will bring up the second IDA, International Docking Adapter, for Node 2 Zenith then to be our second docking port. And when our configuration is complete, we'll have 2 docking ports, Node 2 forward, Node 2 Zenith, and 2 berthing port, the one that we've been using for many years now. The Node 2 Nadir berthing port will be primary, and the backup will be Node 1. And so that's the final configuration to put us in the right config to allow docking again to the International Space Station on the US OS segment. In addition to that, of course, you need the communications assets. We've already done the reconfiguration outside. We put the antennas and ran the wires necessary to allow it to occur, and did some of the reconfiguration inside. SpaceX 7 will bring with it the radio itself. We call it C2V2, and it will be installed sometime after SpaceX 7 as well. Our goal has always been to have a docking capability ready by the end of 2015, although that's probably a little bit earlier than we'll see it need to be used. But that's always been our goal, and we're on track to accomplish that goal. In addition to that, there's of course a number of important spares that are coming up on this flight, as well as a few extra provisions, food, some crew clothing that we're replacing that were on the 59P Progress that was recently lost. But even with that loss, we have very good logistics on board for the entire crew. We're good to the October timeframe if no other vehicles show up, and with SpaceX 7 we get ourselves to pretty much to the end of the year on most of the supplies. So we're in very good shape in that respect. So we'll continue on with research per our normal plan and the reconfiguration per our normal plan, and SpaceX 7 will keep us on track. So thank you very much.
All right, we'll pass it over to you, Hans.
Yeah, good afternoon, and thanks for having me here. Our team has been busy. The SpaceX team has been really busy to put the vehicle together, the Falcon 9, first stage and second stage, and put Dragon on top of it, load it as much as possible except for the late load. In fact, we had a static fire where the vehicle is being held down and the first stage is being fired for around about 2 seconds. We just had that as I was driving up. T0 was at 4 o'clock, and I heard it was a very successful full duration, and that clears the next coming days up to launch on Sunday morning. Launch is at 10, 21, and 12 seconds so far. Again, it's a 1 second launch window to catch the ISS in its plane and make sure that we are in the right orbit behind it, or under it rather. The launch itself will be very similar to the last couple of launches that you've seen. After all, this is I call it CR7, SpaceX 7. It's the same thing, just different perspective. It's the 7th flight. We had quite a few over the last couple years at this point in time. Dragon has been super reliable, and so has been Falcon 9. The primary mission on this one is obviously getting Dragon and its payload up into orbit and phase it into an orbit where it can dock with a station within, I think the time is about 40 and a half hours between liftoff and docking to the station. Flight itself, again, very similar. First stage will burn for a little less than 3 minutes, 160 seconds exactly. Max Qs at the same time, 70 seconds. Those data actually change very little from flight to flight. Second stage will burn to get the rest of the velocity, and then Dragon will be deployed about 9.5 minutes after liftoff. That's the primary mission. Top goal is to get this safely and reliably done. I do want to bring up, we do have a secondary mission, completely experimental. We will perform another landing attempt on a drone ship. Drone ship is out there at this point in time, or it's on its way to its landing point. The first stage after shutdown will flip around pretty quickly and then perform a boost back burn. It will then coast for a while and then perform an entry burn. The entry burn basically lowers the dynamic pressure during the atmospheric entry. And then at the very end, it will perform a landing burn on a single engine and hopefully gently land on the barge. Sorry, the drone ship. So again, this is a secondary experiment. It doesn't the primary mission all focus on the launch team. It's going to be on Dragon. The timing is roughly the same. However, by the time Dragon gets to orbit, the first stage will land on the drone ship. And I guess pending weather, everything is looking very good on our side. Team is in excellent spirits, and vehicle and Dragon are in excellent condition after static fire. That's always the last big test for us. If the static fire goes well, things are looking really good for launch. So hopefully, if the weather plays along, then we're looking at a good launch on Sunday morning.
All right, so we'll hear from the weather officer, Kathy.
Well, weather is not good at the moment, but it does, as you all can hear outside, there's lots of thunder rolling, and we do have actually a severe thunderstorm that's moving into Kennedy Space Center right now, but the static fire is closer to the coast, and actually the weather was holding off long enough for them to be able to continue their operations, and it looks like things are going to hold off just long enough for them to get that done. But when it comes to launch day, we're still going to be okay because they picked a great launch time, 10:21 in the morning. And so with that, thunderstorms are not expected to develop till the afternoon. We did have some more morning-ish thunderstorms, if you will, yesterday because we had very weak flow. But over the next few days, including today, that westerly flow is starting to get stronger. So when you have that westerly flow, pushing hard enough, it holds off that East Coast sea breeze, which is what's causing our weather right now, and that's typically what causes our afternoon weather here. It will maybe possibly form during the day, but on that day, but it's more like 4 to 5 o'clock in the afternoon, and we may even get a West Coast sea breeze across, but that will all be after launch time. So right now we're only forecasting a 10% chance of violating launch commit criteria associated with weather on Sunday for the launch day. Let's go ahead and look at some weather on some displays. We do have the radar picture here. You can see the storm that's forming right over our building that we're in right now, and that is a severe storm that has developed along, or at least we're forecasting for severe weather from it, has developed along the sea breeze here on the East Coast. And what happens is we tend to get outflow boundaries from these storms as well, and they merge, and we tend to get more storms. They sort of start feeding each other. And that's what we've been experiencing the last few days. And we are going to experience more of that the next few days, but later in the afternoon because of the stronger westerly flow. So let's go ahead and look at the launch forecast. You can see that we are just forecasting scattered skies for launch, good weather conditions, winds from the southwest, holding off that sea breeze because it's a little bit strong at 17 knots or 17 miles per hour, and that's good actually for us. The temperature will be 84 degrees, even though it's only 10:21 in the morning. We've been getting pretty hot, but just a 10% chance of violating launch weather constraints. And our primary concern is a cumulus cloud rule, and that's the type of clouds that form along the sea breeze. For the landing forecast, weather is looking overall favorable. The seas are a little bit high, 5 to 7 feet, but nothing that violates constraints. The winds, those seas are high, a little bit high because of the winds from the southwest at 20 knots near the surface. And then if we happen to delay 24 hours, we do have a trough that comes down. That is going to cause more cloud cover in the area and also adds a trigger for thunderstorm development. They tend to form a little bit earlier. With those conditions a little bit more possible, we do have a concern for cumulus clouds, but also even the thick cloud rule violation, which if the clouds are thick enough, you could have an electric field, generate enough electric field to cause a triggered lightning strike. But again, it's a morning launch, so we're only going with a 30% chance of violating launch commit criteria, but the weather will continue to degrade after the launch time. So overall, even though we do have a lot of afternoon thunderstorms in the forecast, the launch time is really favorable when it comes to weather, so just a 10% chance of violating constraints, so good weather for launch.
Great, thank you. We'll now take some questions, and just a reminder to raise your hand, wait for a microphone to come to you, state your name and to whom you're addressing your question. Also, for those of us, those who may be following along online, if you want to ask a question, use the hashtag AskNASA on Twitter, and we'll get to your questions as well. So I think there's a question right here.
Daryl Nail, Fox Orlando. What is it about this booster landing, Hans, that you feel more confident than the prior two?
We had two preceding landing attempts that we used to learn things. SpaceX pushes innovation, and part of that is obviously that you learn from your I don't want to say trials, but it is an experiment or a trial to some extent. And you look at the data, you evaluate this, and then you make correction, and that's ultimately how you succeed, in my opinion, and make a safe landing in the end. The fact that we had two so far gives me just confidence. We had two problems that we solved. I think the odds, it's hard to say what the odds are, if it's better than the last one or not, but there was always uncertainty until we basically solved this problem end to end. There's always going to be some uncertainty about the outcome. But I feel a little bit better.
Hi, Ken Kramer for Universe Today and the Northeast Astronomy Forum. I got a question for Mike and Hans. Quick one for Mike. Can you explain why we need these new docking adapters? What's the difference between the docking adapter for the shuttle and these new IDA adapters? Why we need them? And for Hans, can you talk a little bit about when you might land the Falcon on land? I think you were thinking about it for this one, but you decided not to for some reason. When might we see that in the future? Thank you.
So the answer to the first question, docking adapter, the APAS was really not designed for automated docking. We used a man-in-the-loop for rendezvous and docking, and although the adapter itself probably could have been made to work for us, it was such an older technology that we had to design the mating half anyway, redesign the mating half. And so we took that opportunity to work with the international partners. In fact, some countries outside the international partnership participated as well to design what we call an international docking system spec. And so our dream is to have one common docking system that all countries will use to give us commonality as we reach further and further into space, to ensure that we have an ability to support one another as we start to collaborate in other efforts in low Earth orbit and well beyond. And so the International Docking Adapter is really the first step for a sort of universal docking system that and really was a first step in exploration and bringing all the countries together in exploration. So in that respect, it was a big success. But basically, we needed a new system anyway. We couldn't use the old system. And this system is really designed for automated docking if that becomes necessary.
Yeah, and regarding the landing on land, I have to admit that I forgot what that is, the next one. But it's not driven necessarily by schedule, it's largely driven by performance. You got to have enough propellant on the first stage so you can turn the stage around and then fire all the way back to land. Obviously, that requires a little bit more performance than what we do right now. And so we would need a mission that is lighter, basically, or has a lower energy orbit in order to perform that. I believe it is a mission by the end of this year. In either case, we want to make sure that this is safe and reliable. And that's when we're ready, we will do this.
Jim Siegel, I'm with the Celebration News and also Spaceflight Insider. A follow-up question for you, Mike, regarding the docking adapter. So the one you're going to be installing is kind of a universal docking adapter, if you will. So how many other docking and berthing nodes are there, and are those on the space station, and are those going to stay in place as well, or is there going to only be this single, eventually this single universal docking system?
Yeah, that's a great question. Our Russian colleagues have a number of docking options. And so today they use a probe and cone. It's a relatively, it's a smaller diameter. I won't say it's relatively small, but it's a smaller diameter. It's typically, probe and cone is a simpler system, more reliable and lighter. Probably most important is lighter. However, when we were designing or deciding what this international spec would look like, we wanted to keep the androgyny of the APAS. That is, that you can be either half and come in. So if you need to bring another spacecraft into dock, or one spacecraft needs to go to the one that's not working anymore, this was really about supporting each other, particularly in contingency cases. So you can always plan to have the cone on one side and the probe on the other. But in the event that you had a contingency, you're trying to save a spacecraft, and you hadn't considered that, if you have androgyny, then any one can dock to the other. And so when we were building the design, we knew we needed docking capability on station for the new vehicles that were going to come up to ISS, the new crew vehicles would come to ISS. We decided we would go out and do this look internationally, find out what everyone thought was reasonable, and it came out the idea was you want to try to have androgyny. That was an important requirement. With that comes a little more complication in terms of the design. and weight associated as well. So that's why we chose those systems that are on the U.S. side. So we'll put 2 of those on the USOS, and that's how we will have docking on the USOS. Because of the investment our Russian colleagues have made, even though they participated in the international docking spec, they're going to continue to use probe and cone on the Russian segment. And so they have 4 docking ports that have probe and cone docking capability. And then on the U.S. segment, we have the CBM interface, the berthing interface that Dragon will utilize. We built that type of interface in order to have very strong structural interface between elements. And then when we decided we were going to use berthing for these cargo vehicles, because you get the much bigger hatch, I can get much larger cargo through that than I can through a hatch, even for the new docking adapter. You have now these 50-inch hatches and a very strong structural attachment as a result of that. So when we got around to berthing, it was just natural to go ahead and continue to berth to those. So we have, when we're done with our configuration, we will preserve 2 berthing ports like we have today, but now the 2 berthing ports will be Node 1 nadir and Node 2 nadir. We'll have 2 docking adapters on the U.S. segment that are the International Docking System Spec Standard or International Docking Standard, and then we'll have the 4 probe and cones that are on the Russian element. That's where we're at today. And as the Russians plan to add a couple more elements, they will preserve the 4 docking ports, and they will continue to be probe and cone just because of their investment in this time.
Question there, and then we'll go to one on the phone.
Hi, I'm Niels with the NASA Social Group. A question for Hans. If everything works out with the landing of the first stage, what's going to happen to it, and are you planning to refly it?
Well, obviously it will be towed back to the harbor. It's not quite clear right now, but how long this takes. Need to be safe. Need to make sure that pressure's out, everything is saved, tied down, and then move it back to the harbor. From the harbor, I believe the plan was to bring it back to Texas, and there will be tests with the vehicle to make sure that you can burn it again, fire it again. Basically, it depends a little bit on what we find. So the first thing, obviously, is a really thorough inspection of the vehicle, where we see if there's any damage to re-entry, or how well in shape it basically is after the re-entry. Given the way we enter and given the heat shield design and everything, we think it's going to be in very good shape, and we can fly it pretty quickly after that. But yeah, the vehicle is designed to fly multiple times to be reusable, and we're going to test that.
Great, thank you. And we have a question from Bill Harwood from CBS on the phone.
Yes, hi. A quick question for Hans, if I can. Could you give us an update on the status of the enhanced engines you guys are developing, how the testing's been going? I was curious as to how much testing is required for certification and when we might see those guys fly.
I guess you probably referring to the upgrade that we perform a couple of vehicles from now. Those tests are underway. We perform engine tests at this point in McGregor, both with the flight engines and with the qualification engines. So far, from what I hear, tests are going pretty well, and the team is on schedule for the upcoming launch on this particular vehicle. I believe it is Flight 21, if I'm not mistaken.
Thanks.
Okay, we have a question here.
Hi, I'm Elizabeth, and I'm from Science World in Vancouver, British Columbia. I'm with NASA Social. And I'm curious about this 1 second window situation. Super fascinating. What would happen if we missed it?
It's actually not that big a deal if you would miss it by a couple of seconds. So if you miss it by like a minute, that would be bad. But so what happens is basically it's the orbital plane of the space station, and the Earth rotates under it, basically. Yeah. So we basically calculate the offset based on the burn time that we have, which is 9 minutes and I think it's like 40 seconds. Yeah. And so the goal is the velocity vector to have the velocity vector exactly in that plane. And the reason this is important is because this is a pretty long velocity vector. It's 7.88 kilometers per second. So in order to move that velocity vector a little bit to the left or a little bit to the right, you need a lot of propellant. And by that time, Dragon is on its own. So if Dragon has a lot of propellant, you can correct for those inclination or ascending node errors, basically. We're trying to preserve as much propellant as we can for the actual rendezvous and docking and the on the space station, and so we're trying to really hit the orbit very well. But as I said, if you miss it by 10 seconds, you pay a certain amount of propellant, a couple of kilograms. If you miss it by 30 seconds, it's going to be more, and if you miss it by a minute, that might be a lot already. Yeah? It's at the end of the day, it's not that difficult for us. We automate a lot on the ground system. It is basically what we call an auto sequence. It's a computer that takes over on the ground. You push the button, the computer synchronizes at T-10 with the launch time. So at that moment we are hands off, and it counts down, and it launches at that exact second. It's not that difficult. And 10 seconds later, there would be no benefit for us to have the ability to stop and say, no, I want to do this 10 seconds later, I want to do this 10 seconds earlier. Yeah? It's just, at that point in time, it's automatic, basically. It sounds dramatic, however.
It's very common. All of the vehicles that fly to a point, they're trying to chase something that's moving in space. Because you don't have infinite performance. I mean, you typically load up your vehicle as much as you can. So in shuttle, we had about a 5-minute window. The Soyuz has about 10-second window. They're very, very short windows when you're trying to rendezvous with an object in space.
We have a question back here.
Hi, my name is David Liano. I'm with NASA Social, and my question is for Kathy or Hans. Regarding the weather around the barge for trying to land the first stage, do you know what we can expect for that day? And would it be an issue?
We're not looking for issues. We think we may see some isolated showers in the area, but those won't be an issue. And we do expect winds to be from the southwest gusting to 20 miles per hour. The only thing that causes is a 5 to 7 foot seas. But again, none of those are constraints for landing.
Yeah, the maximum weather is really pretty high on that drone ship. You got to keep in mind, primary mission is Dragon, space station supply, and that is on the side. So obviously the weather for launch is much more important than the weather for landing for us.
Okay, we have another question on the phone from Stephen Clark of NASA Spaceflight Now.
Hi, Stephen Clark with Spaceflight Now. A couple of questions. First for Hans, what's next after this mission? I know you have Jason 3 at Vandenberg, but what are your next couple of launches at the Cape? And for Mr. Suffredini, a couple. First, do you have the cost of the IDA or both IDAs? And also, you have 2 cargo missions going up to station this week. How much does this relieve the pressure on your supply chain after losing Orb 3 in the Progress? I know you have consumables until October, but you're trying to get back to a 6-month padding, if I understand. Where does this get you with these 2 deliveries coming up? Thanks a lot.
So in terms of the upcoming launches, I'm actually working very hard on this one on Sunday. So for me, it is hard to look much beyond that. But let's see, this is 20. The numbers are out of order, but right now the numbers present when the vehicle leaves the factory, basically. After that, you're right, it's 19 or Jason 3 from Vandenberg. It's going to be exciting, a much shorter commute for me. And then we have, the next one is 21, is SES 9, which is a GeoBird again, which is one of our standard launch profiles by now. And then after that comes CRS or SpaceX 8 or CRS 8, and I believe CRS 9 shortly after that. So it's going to be a whole bunch of launches later this year. We're going to be very busy, and I'm certainly looking forward to many flights over here and launches from the Cape.
Let's see. The cost of IDA, well, I don't remember IDA off the top of my head. We had to design both the docking system, which is of course much more complicated than the docking adapter on ISS, which doesn't have to have the same functionality. It's receiving a docking system which absorbs the shock and pulls the spacecraft in for the hard dock. So it's much simpler. The entire system has been over $100 million in terms of development, but I couldn't tell you what part of that. A much smaller part is the cost of the IDA itself. In terms of logistics, you said it right. We're good to October. SpaceX 7 gets us to towards the end of the year. We're getting pretty close to 6 months. 6 months isn't a requirement. It's not a hard requirement. We don't stop bringing other supplies to ISS in order to get back up to 6 months. We're trying to get there while still carrying the spare parts we need and of course all the research we need to fly. So, but I think by the end of the year that we'll be kind of closer to where we'd like to be, which is closer to about 5 or 6 months. And we'll try to stay there and gradually get ourselves back all the way back up to 6 months. But you can see why we do that. We've had really no impact to research at all, given both the Orb 3 anomaly and this recent progress anomaly. So that's the point why we do this. Spaceflight's very, very challenging. We expect occasionally that things won't go quite right. That's not tomorrow, but in general that can happen. And so we try to protect ourselves for that.
Yeah, Jared Hayworth with the Mars Society and Spaceflight Insider. I have a question for Hans. Could you talk to us a little bit about the challenges or concerns in bringing the Falcon 9 first stage back into Jacksonville Harbor, particularly since the drone ship docks near a fairly active cruise ship port?
I don't think I can talk a lot to that, frankly. Well, part of this, it goes back to primary mission, secondary mission, right? So I dedicate 100% of my time to the primary mission, and I'm working mission assurance, so that is my main job. I've been paying more and more attention to the landing attempts too, because that obviously you want to get this done in the long run, so it is important. But I haven't looked too much at the details in terms of towing it back to or bringing it back to Jacksonville. I pretty sure we will do this such that it doesn't collide with cruise ships or anything else. Right. I know that the cruise ships are next to it and they're really watching us. I know this, but I don't think that will be the case when the drone ship comes back. Yeah.
This is a brief question for Kathy. Coming from Southern California, I'm struck by the weather here. You must have a really difficult job. I know that the launch site was historically selected for many different reasons. If you could move it anywhere else, where would you move it?
Well, actually, this isn't as bad of a location as it sounds, because cold temperatures are really bad are not very good for rocket fuel and moving fuel and rocket components. So in actuality, we do have to protect for lightning around here, but we also get the benefit of not having the cold temperatures that you can have in other locations. So if you could find a place that was warm with no lightning, then you'd be great, but you have to strike that balance and then also still be able to have the access that you have here at the Cape and KC from water, from land. So I know people talk about our hurricanes and our thunderstorms, and we certainly, you can see it when you drive around the launch pad. You see the lightning protection that we have, and we do a lot to mitigate that. We also provide lightning reports after lightning events so that our customers know what actually occurred cloud to ground stroke wise when it comes to lightning. So we do a lot to mitigate, but our warm temperatures, I think, offset all of that.
There's a question back here. There's one back there and then next to you.
Hi, I'm Brenda from Space Trippineers, all the way from Western Australia, Perth. I work with kids and I've got a bunch of questions that they've asked me to ask, and this one's for you, Kathy. One of a grade 8 wanted to know what is the maximum time frame that you would be able to determine a launch. So how many days out can you actually determine when a launch is, and is there anything that can go wrong in that process?
Well, that's a great question from them. We usually feel pretty good within the first 3 days. We feel really good forecasting 3 days out. We feel confident going out to 5 days. Once you start getting beyond 5 days, we put a lot of caveats into that forecast. And then if somebody wants to know about next year or a certain time of year, we have a lot of good climatology information that we can provide. So we can tell them the best time of year to launch, the best time of day to launch. We even have hourly data that says when's the most likely time. This time of year we're going to see thunderstorms or lightning in the area. So for immediate forecasts, though, I usually tell people we can give you a real detailed forecast out 3 days, even down to hours. But then out to 5 days, we kind of like to go more. Morning is good, afternoon's good, and then beyond that, we sort of start getting more into climatology or overall general weather patterns for this area.
Hi, I was hoping you could describe the difference between berthing and docking on the space station, some of the advantages, disadvantages associated with each method, what they might be used for. And Hans, I'm from Jacksonville. It's a very small cruise ship, so you guys should be fine, I would think. Thank you.
Advantages and disadvantages. Well, they both have advantages and disadvantages. So we have this conversation all the time. From a logistics standpoint, the biggest hole I can get to bring spare parts through is what I like the best. And so berthing really brings us that big advantage. That's a much larger hole to get objects through than if you dock, by the very nature of the beast. Berthing also, from a blood pressure standpoint, for a program manager, berthing's a little better because the spacecraft just sneaks up, and about 10 meters away it stops. And you're just sitting there staring at it, go, oh, good, it's not coming any closer. And you grab it with the arm and you attach it, and it's all good. Docking, you got to fly it right in. And in fact, if you go too slow, that's not good either, because you got to keep the right, basically, energy on the spacecraft so it follows the path you want it to follow. So it does have to approach at some speed, and at some point you don't have any other choice. You got to keep going the rest of the way. Now, I say that sort of facetiously. The way the systems are set up, by the time you get to the point where it's really the point of no return, the odds are very, very small that anything can go bad enough wrong that you won't complete your docking. But you do have more energy in that case. In a berthing case, basically your delta velocity is 0 by the time you get to 10 meters away, and for docking you have to have a delta velocity in order to actually dock. But the advantage of docking, it can be done in an automated fashion. So if you have a need to get a spacecraft there first, which there are a lot of scenarios, particularly with future work we're considering for Mars and whatnot, you want to put your logistics there in advance and things like that. You're going to want to dock. You're going to want to have this way to dock autonomously. And today we don't know how to, well, I was going to say we don't know how to, we haven't devised a way to do berthing in an automated fashion, although that is something that we're talking about. But those are the biggest differences.
Do we have any more questions in the room? Another question from the students? Sure.
This one's for Hans. I'm just going to take a chance. One of the kids have asked, in regards to SpaceX, do you guys do internship for young kids to come through to experience space travel programs? Do you have something like that in place? Is that something you're going to have in the future?
I would refer them to the website, frankly. I know we sometimes do special programs. Generally, we want our interns to have some basic knowledge in math and science. But I know we have some special programs, so I would really refer to the website and see what's on there, or send an email to Emily over there.
And NASA has lots and lots of education programs. If you go to nasa.gov/education, you can find lots there. Question here?
Hi, Kyle Brown, U.S. Launch Report. This one's for Hans. Can you speak about the difficulties you encountered when installing the international docking adapter onto the Dragon capsule?
I don't think there were any. I get lots of reports. I don't recall there was no event related to the adapter. So my assumption right now is this went pretty flawless.
Awesome. Thank you.
I must say, regarding the docking adapter, I think this is actually pretty cool, because it does play right into our next Crew Dragon program. So it is something that we bring up for our own future, and so we're really motivated to bring this up. And I personally, I've been pushing external payloads a lot. Those are big pieces that build up the station. So I really think it's pretty exciting to do this.
Another question here.
Hans, you mentioned, well, I just heard one comment about blood pressure, but with each one of these specific missions having you have a real specific aspect to the mission, but each one is also experimental and just space travel in general and getting things up and how they're coming down. What's your anxiety level like going into each and every launch?
I think my anxiety level on we've done this now, this is the 7th time, 20 launches. I've been on every launch at SpaceX so far. I'm still excited about it. I still go through a lot of data. I review stuff very carefully, but my overall blood pressure did go down over time. And on this one in particular, I have a fairly healthy blood pressure overall.
One final question.
Yeah. Hi, Janet Heaton with the NASA Social Group, JK Heaton on Twitter. But I had a question from a Twitter friend, and I think you touched on this a little bit, Mike. But he's asking, is there a design board progress towards the universal docking aperture? Will there be no more adapters?
Okay, I'm not sure I understood the question, but I think I might be able to answer it. By the way, this is a favorite technique, right? When you take this training for media training, they say, answer the question you want to answer. So I probably should have told you that, and I actually never had media training, so there you go. The internet I refer to as International Docking Adapter, and we call it that because we're adapting the APAS to this new adapter ring, and essentially it has an APAS on one side and it has this new interface that is compatible with the International Docking System specification. So that's why we call it an adapter. We're adapting our docking system. The future docking systems that will dock to space station, and anybody can build it. The spec is for everybody's use, and SpaceX is using it to build theirs. We built one. We designed and built one as well that we intend to use in the future, and it's a design that anybody can build. But these then are the docking systems that not only will dock to station, and we call it the adapter, but can dock to other docking systems on other spacecraft. So we call ours, the thing that's flying up now is very simple. We call it an adapter because we're just adapting what we already have on station to meet that spec. But the docking systems themselves are made to dock with each other. So maybe that's the confusion.
Okay, thank you all for joining us today to talk about pre-launch preparations for Sunday's 10:21 a.m. Eastern Time launch. Preparations will continue and our briefings will continue. We have another briefing scheduled for 2 p.m. tomorrow on Saturday. That's 2 p.m. Eastern Time. We'll be talking about the future of the International Space Station, student science, and commercial crew. We'll have 2 students who have experiments flying aboard. They're middle school students who will be joining us to talk about their investigation that will be flying to space. And we'll have members of the International Space Station program, commercial crew program, as well as Boeing and SpaceX to talk about commercial crew and preparing for U.S. commercial crew. So join us at 2 p.m. Eastern Time tomorrow and follow along with all of the launch preparations at nasa.gov/SpaceX.